the previous module, we introduced the scientific method and said that experiment is one of the important steps involved. Remember, with the experiment you get results, which generally consists of two parts, the number and the unit. First we talked about the number and how to present it using scientific notation. It is important to keep in mind that almost all measurements are approximate, so using high quality tools gives you more accurate results, or we can say high quality results. To differentiate between high quality and low quality measurements, we covered the significant figures concept. So the more significant figures in the measurement, the higher the quality of your measurement. We also discussed the zero digit and in which cases it is considered significant or not. Then we covered the operation rules for significant figures. So in addition and subtraction, we look at the least number of decimal places. In multiplication and division, we look at the least number of significant figures. In some calculations, you might need to apply both rules as you have a mix of different calculation methods. In this case, you do the calculation steps one by one and apply the rule in each step as you progress in solving the question. After that, we talked about the unit and covered the SI units. We also discussed the conversion factor method to convert from one unit to another. Now, let's move to Module 2. Today's topic is related to matter, elements, and compounds. Module 2 will be covered in two videos. In the first video, we will discuss matter, the physical states and properties of matter, classification of matter, and finally, we will discuss the physical and chemical change and how to identify each change. The second video will cover the elements and the periodic table. Then we will discuss the two types of compounds. The learning outcomes of the first part of Module 2 are: define matter and the three physical states of matter, differentiate between homogeneous and heterogeneous mixtures, and differentiate between physical and chemical change. Matter is everywhere around us, and every day we come into contact with countless kinds of matter. We can broadly define matter as anything that has mass and occupies space. Matter can exist in three physical states: solid, liquid, and gas, and we will study each of them in detail in this module. Matter is classified into elements, compounds, and mixtures. We will study each of them and discuss the relationship between those topics and how they are linked. As mentioned in the previous slide, there are three states of matter: solid, liquid, and gas. Let's study the property of each state, looking at the example of water. For the solid state, on a molecular level, we notice that molecules are arranged in a regular way. The molecules cling rigidly to one another and cannot change position or move freely, so they keep the same distance between one another to maintain the same position. This arrangement will create the shape or crystal and give the solid matter its volume. Although the molecules cannot move freely, they can vibrate in their position. For the liquid matter states, on a molecular level, we notice that molecules are condensed and packed together, but they can move and collide with one another. So the molecules change their position all the time. Therefore, liquids have volume, but no shape. The shape of the liquid is determined by the shape of the container. The molecules can also vibrate in their position. For the gas matter states, on the molecular level, we notice that molecules are looser and can move more freely than liquid. There is a huge space between molecules. So gas takes the shape and volume of the container. So these are the properties of each state. Remember that the state of the matter can change from one to another depending on the temperature. For example, heating ice will change the matter from solid into liquid, water, and continuing to heat it will change the matter into gas, steam. Cooling the steam to less than 100 degrees Celsius will change the state from gas to liquid, and so on. The easiest way to classify matter is by looking at the flow chart. As you can see, matter is on top of the chart, and then we can go into smaller components that make up the matter. To make things easier, we will build this chart together. The term matter refers to all materials that make up the universe. A substance is a particular kind of matter with a definite and fixed composition, sometimes known as pure substances. Substances can be classified as either elements or compounds. Elements is the smallest unit for all chemical reactions. In chemical reactions, we don't create or destroy elements. So the element that goes into the chemical reaction, the reactant, should stay in the product. We will cover the elements in more detail later in the lecture. When two elements bind together, they form what we call a compound. For example, water is a compound that consists of the elements hydrogen and oxygen. Sodium chloride, or table salt, consists of the elements sodium and chlorine. However, when two different substances come together, they form a mixture. For example, water inside a beaker is a substance. When you add salt to the water, it becomes a mixture, because you now have two substances, the water and the salt. Mixtures can be either homogeneous or heterogeneous, and we will learn the difference between those two types in the following slide. To differentiate between homogeneous and heterogeneous mixtures, let's consider the following examples. When we put salt in water and stir them well, we get a homogeneous mixture, because the salt is distributed uniformly throughout the water. In the second example, we add iron foil to sulfur powder. When we mix them together, we get a heterogeneous mixture, because the iron foil is not uniformly distributed within the sulfur. We can use the following analogy to recognize mixtures. In the first example, we added salt to the water and stirred the mixture well. If we take a small sample from this mixture, or what we call a subsample, we will find it has the same property as the original mixture. So in homogeneous mixtures, the subsample is representative, as it has the same properties as the original mixture. On the contrary, heterogeneous mixtures produce subsamples that don't represent the compounds. For example, if you fill a sand bucket from the beach, you get a heterogeneous mixture that may contain water, sand, rocks, and other stuff. If we take a subsample from this bucket, we find that it doesn't represent the property of the mixture, as we might get only sand in the subsample, but the mixture has also water and rocks. So, in heterogeneous mixtures, the subsample does not have the same properties as the original mixture. Now, someone might say that if a compound consists of two or more elements, why don't we call it a mixture? Compounds have a fixed ratio and fixed properties. For example, water has 1 oxygen and 2 hydrogens, so the ratio is 1 to 2. The fixed properties of the water include boiling at 100 degrees Celsius, freezing at 0 degrees, and a density of 1 milligram per mil. It doesn't matter where you get this water from, it will always have the same properties. Mixtures, on the other hand, don't have fixed ratios or fixed properties. For example, the salt in water. You don't have a fixed ratio, as you can add 1 spoon of salt to the water, or you can add 2 spoons, or 3, or so on. The density of the salty water is not fixed as well, because it depends on how many spoons of salt you add. Similarly, the boiling point and freezing point will be different every time, depending on how much salt you add to the water. So in compounds you can't adjust the ratio or change the properties, where in mixtures you can control those variables. Now, how can we separate a compound to its elements? In chemistry we can write elements and then an arrow to the compound. This is what we call a chemical reaction or chemical change. So, for example, oxygen and hydrogen bind together to produce water. This is a chemical reaction. Similarly, when water breaks down to oxygen and hydrogen, we call that a chemical reaction too. On the other hand, when substances form mixtures, or mixtures separate into substances, it happens through a physical change. For example, adding the salt into water produces salty water through physical change. Why do we call it a physical change? Let's look into that in the next slide. When we add salt and water, we stir to mix the two substances, and this is a physical change. Similarly, if we want to separate the mixture, we boil the water so the salt will stay behind, and then we can condense the steam to get the water by itself. This is also a physical change. Let's look at another example, the sand bucket. How can we separate this mixture? By using a filtration apparatus, the water passes through and the sand with the rocks are left at the filtration paper. Again, this is an example of a physical change. How can we differentiate between physical and chemical change? To do that, you need to look at the properties of substances. Each substance has a set of properties that form the characteristic of that substance. Properties are classified as either physical or chemical. Physical properties are the inherent characteristics of the substance that can be determined without altering its composition. For example, color, taste, odor, state of matter, density, melting point, and boiling point are all physical properties. Chemical properties describe the ability of a substance to form new substances, either by a reaction with other substances or by decomposition. So to recognize if the change is physical or chemical, we need to check the chemical identity of the matter before and after the change. As the name suggests, the physical change involves change in the physical properties, and the chemical identity of the substances remains the same after they come together. For example, melting the ice to get water. Ice and water have the same chemical identity of H2O, therefore this change is physical. Cutting a big piece of wood into small pieces is also a physical change, because both the big and small pieces have the same chemical identity before and after the change. In the chemical change, the chemical identity of the elements changes when they come together. For example, oxygen element helps to burn things, and it is used in industry to produce a lot of heat. The hydrogen element is a highly flammable gas. However, when they join together by a chemical reaction, they produce water, which has completely different properties. Another example is sodium metal, that is a highly reactive metal, and chlorine gas that is toxic. When they come together, they produce sodium chloride, which is the table salt that we eat. As a general rule, going from elements to compounds and vice versa is considered a chemical change. Going from substances to mixtures and vice versa is considered a physical change. This is the end of video 1. Please proceed to the second part of module 2 and watch video 2 that will discuss the elements and compounds in detail.